Hello 3D printing friends. Today on the BV3D channel we're going to take this Anet ET4 Pro out of the box, get it put together, and see if we can get it to print something. Stick around and we'll get into it right after this. I'm Brian and you are watching BV3D. Hi, welcome back. Hey, if you're new here and you're wanting to learn about cool 3D printer upgrades, 3D modeling, and other 3D printing related stuff, start now by subscribing and clicking the bell so you don't miss anything. Now, recently, Anet sent their ET4 Pro 3D printer to me to take a look at. Now, for better or worse, you can't talk about Anet without talking about the Anet A8. People who have been involved in consumer level 3D printing for a few years will be familiar with the A8 because it has the unenviable reputation as a 3D printer blamed more than any other for house fires. One thing contributing to this reputation is the fact that the firmware the A8 shipped with didn't have thermal protection features enabled. Now, thermal protection in firmware is designed to prevent a printer from going into meltdown. So a lack of thermal protection is bad because the hot end can get hot enough to smoke or even cause plastic to catch fire, which can be a big problem if your printer is made almost entirely of plastic, like the Anet A8. So in an attempt to get past the A8's reputation, about a year or so ago, Anet released a new version which they call the A8 Plus. Now, the Plus version has a larger build volume than the original, and it's constructed of extruded aluminum instead of acrylic plastic. But weirdly, they still sell that original acrylic A8. Now, in addition to the A series printers, Anet has released an ET series consisting of the ET4 and ET5. Each of these is available in standard, X, and Pro versions. The ET4 series is Ender 3 sized with a build volume of 220 by 220 by 250 millimeters, and the ET5 series is CR10 sized roughly with a build volume of 300 by 300 by 400 millimeters. So what are the differences between the standard, X, and Pro editions of each printer? Well, the Pro edition has silent stepper drivers while the standard and X editions don't. The standard edition has red accent hardware, the X edition has blue, and the Pro edition has black. Now, the X editions seem to be the odd ones out of the lineup. In the ET4 line, the X edition doesn't have automatic bed leveling while the standard and Pro do. In the ET5 line, the X edition includes a 1 kilogram spool of filament and costs a few bucks less than the ET5 standard, which doesn't include filament. It's really hard to make comparisons between the models because they don't have a consistent page layout on the Anet site and they don't all have the same information on each printer's page. The X edition printers in particular have almost no information at all on them. But they all seem to share the following features. They have color touchscreen interfaces, thermal protection enabled in firmware, they can resume printing after a power failure, and they have filament runout sensors. So the printer Anet sent to me is the ET4 Pro, which is the top of the line in the ET4 series. That means it's Ender 3 sized, has silent stepper motor drivers, black accent hardware, and all the shared features that I just mentioned. Having built an Anet A8, which requires peeling protective paper from plastic prior to put together, I'm curious to get this Anet assembled. And so with that, it's time to cut open the box and get all the parts out. Let's just get all the pieces and parts out of the box and get them all laid out on the bench. First, we'll get the packing materials off the top. There's a bag with the assembly and user guides. There's a uselessly small filament sample. There's a bag of tools. There's the X-axis belt. There's the bolts to hold the printer together. There's the USB card reader, the micro SD card, and a spare nozzle. There's the X and Z axis assembly. There's the X carriage assembly with the hot end. There's the base of the printer, and underneath, the power cord and spool holder pieces. Looking at the underside of the printer, you can see that the main electronics area is enclosed, but the back third is open underneath. Oh, and there's also a build tack-like print surface included if you don't want to print on the plain glass bed. I'll get the box and the packing materials out of the way. Oh, looks like there's some extra foam between the bed and the body of the printer. Now, with everything out of the box, it's time to get the printer put together. In theory, this should be simple to do. Bolt the X and Z gantry to the base of the printer with the 4M5 bolts, mount the X carriage on the X-axis arm, and then plug all the wires in. But getting the X and Z gantry bolted on was made a little bit difficult by the fact that the wheels on the X-axis arm were set a little bit tight. I was able to get one side bolted in easily, but not the other. But after loosening the eccentric nuts on them, I was able to get the bolts in on the other side, and then I could proceed. But apart from that, everything went together pretty easily. With the X and Z gantry bolted on, I cut the zip tie holding some foam padding in place on the Z axis. Now, sadly, Anet doesn't include flush cutters, so I had to use a pair that I got with another printer. Then I adjusted the eccentric nuts on either side of the X-axis arm for a snug fit. Next, I looped the X-axis belt tooth side down over the X arm. Then I slid the X carriage onto the arm. With the carriage mounted, I adjusted the eccentric nut on the X carriage to get a snug fit between the wheels and the arm. After that, I connected the ends of the belt to the carriage. Tensioning the belt was a simple matter of loosening the screws on the X-axis stepper motor, pulling on the motor to add tension to the belt, and tightening the screws. There's a ribbon cable and a mesh wrap that's bundled up in the underside of the printer, so that needs to be set free and fed through the big hole in the side of the printer. Then the cable head plugs into a breakout board on the X-axis arm. After that, plug the free end of the Bowden tube into the extruder assembly. Then connect all the little plugs into the appropriate sockets on the breakout board. They're all labeled, so you just match up the label on the cable with the label on the socket and plug them all in. There are rubber trim strips inserted into the Y-axis extrusion to keep the bed from moving during shipping. Remove them so that the bed can move freely. Then plug in the Z-axis stepper motor. If necessary, adjust tension on the Y-axis belt by loosening the screws holding the stepper motor in place, pulling on the motor to apply tension, and tightening the screws. Oh, make sure that all the rubber trim strips are removed from the Y-axis. Check that the bed doesn't wobble. If it does, adjust the eccentric nuts so the wheels are snug against the aluminum. These can be a little awkward to get to because they're up under the bed. I turned the printer partway on its side so I could see what I was doing. You'll also need to mount the spool holder to the top crossbar. There are 2 screws and T-nuts that hold the spool holder in place. Get the screws threaded into the T-nuts, then line them up in the top crossbar and tighten them to secure the spool holder. To finish the spool holder, attach the axle part with the included nut. The printer comes with a glass plate clipped to the heated bed, but I almost never have good luck printing on plain glass. So I unclipped it, removed the protective peel on the aluminum plate, and installed the included build tack-like print surface directly onto the bed. Now this is just a peel and stick process, but I can almost always count on this kind of surface to keep a good grip on the filament during a print job. The printer comes preset for the line voltage in its destination country, so this one is a 110 volt printer. There's even a sticker next to the power socket to remind you. All that's left at this point is to plug it in and turn it on, and then we can run through the leveling process and print a pre-sliced G-code file from the micro SD card that came with the printer. So this is how you do the automatic bed leveling. Tap Prepare, then tap Level. On that screen, if Auto isn't selected, tap it. And down here, it shows the current Z offset value. Tap OK, and the printer will home the nozzle in the middle of the bed. When it comes to rest, use a sheet of paper to test the distance between the nozzle and the bed. Adjust the nozzle up or down until you can slide the paper with just a little bit of friction. Then tap Auto again and confirm that you want to start leveling. The printer will perform a 25-point probing of the bed to get a mesh from it. This can take a long time because for some reason, Anet has the firmware set to move very, very slowly between probing points. I think this could be sped up considerably if the printer was moving at 100 millimeters per second between probing points instead of what looks like 10 millimeters per second. When it's done, you'll see a grid of probe values displayed on the screen. Even though it probes a 5x5 grid, it only displays a 3x3 grid, probably due to space constraints on the screen. Okay, now that it's leveled, we can load some filament and then print one of the files on the included microSD card. Loading filament is fairly standard on the ET4 Pro. Start by clipping a point onto the end of the filament. Oh, one thing Anet doesn't include in the box is a set of flush cutters, so you'll need to supply your own or use something similar. The utility of flush cutters in 3D printing is not to be underestimated, and I think that they should be included with every 3D printer, and usually they are. Then insert the filament through the filament sensor into the extruder assembly and on into the Bowden tube. Now make sure that the nozzle is high enough off the bed to give the filament enough room to purge out through the nozzle. On the LCD, tap Prepare and then Change Filla to get to the Change Filament screen. Tap Load to start the loading process. The printer will heat the nozzle if necessary, and then it will start pushing the filament. Now I didn't notice at first, but Anet lets you choose 3 different amounts of filament to load. The default setting is 30 centimeters, and this should be just about enough to get from one end of the Bowden tube to the other, although I didn't notice these settings at the time. I had manually pushed the filament through the Bowden tube until it stopped, and then told it to load, and wow, did it purge out a bunch of filament. Now I've got a small modern art piece. Lovely, isn't it? Now, by the way, this is a Silk Metallic Rainbow PLA. So with the filament loaded, we'll insert the card and start a print. There are 2 printable pre-sliced G-code files here, dog and pig. I'll select the pig file and start that printing. And now here's a time lapse. Like most pre-sliced files included with 3D printers, this one includes a raft. If you're new to 3D printing, a raft generally ensures that you'll have a successful print, even if the distance between the nozzle and the bed isn't optimal. The raft is like a small 3D printed platform that gets printed first, and then the model gets printed on top of that. It adds a little extra time to the print, but again, if this is your first time printing and you haven't yet got a good feel for what a good first layer should look like, a raft will help ensure success. One other tool that's usually included with a 3D printer but which Anet doesn't include is a putty knife or scraper. Now this is invaluable for getting the printed things off the bed. So I'm using one that I got with another printer, and with it I can get the raft separated from the bed. There, see? Then I can pop the raft off the bottom of the print, and with that gone, I can remove the supports that held up our pork bellies. So this took 5 hours and 15 minutes to complete. I think the end result was pretty good. There are a few strings between the pig's ears that can be easily pulled off, but it's not that bad. There are a few little retraction marks on the pig's face where the slicer was placing the Z seam, but I think this silk filament tends to enhance that sort of thing. When I slice decorative models, I usually align the seam at the rear so it doesn't stand out nearly as much. Overall, I think the pig came out pretty good. Okay, we've managed to get the printer out of the box, get it assembled, and print something with it. Now, let's talk about it. First, a couple of notes about the hardware. The printer itself seems pretty sturdy. Belt tensioning is simple but effective. You loosen the screws holding the X or Y stepper motors, pull them to set the tension, and tighten the screws, and you're done. Now, the hot end fan is controlled by the main board, so it's not on until the hot end is at 50 degrees C or higher. And this is a nice feature that keeps the noise level down. The silent stepper drivers work to move the motors quietly, as you would expect, except for the Z-axis motor. The vibrations from that one, particularly during all the up and down motion of the leveling process, resonate loudly, and the printer body amplifies them. Now, the bed has those good yellow springs that I like, but the bed's power cable, likes to hang out around the Y-axis limit switch area, and I'm concerned that it's going to snag there at some point, and I can't seem to convince it not to do that. And as I mentioned before, the printer doesn't come with flush cutters or a scraper/putty knife. Next, I want to go over the contents of the micro SD card. Now this won't take long because there's not much on it. Anet includes a Windows version of Cura, but no Mac version. This is typical, but really why not put the Mac version on there too? And while there are two pre-sliced models, dog and pig, the card does not contain the STL files for them, so you can't slice your own and compare your printed results to the pre-sliced files. There is a text file with some starting and ending G-code. It includes slicer-specific placeholder text, for example, setting temperatures at the start of a print, but there's no indication as to which slicer these specific placeholders belong. So unless you're familiar with G-code, and in particular the text placeholders that your slicer uses, just copying and pasting this into a slicer may or may not work as expected. Next up, the documentation. Now, while the assembly guide is actually pretty clear in an IKEA sort of way, the operation guide is a bit more cluttered. They're cramming so much information into a tiny 4-page flyer that it's difficult to follow. Notably missing from the documentation is any sort of information about how to configure a slicer for use with this printer. On Anet's website, there are instructions for configuring an older version of Cura, and there's a Cura printing profile for the ET4 Pro, which Anet makes available for download, but it's not a machine profile, it's just the print settings. Now fortunately, Cura does include a machine profile for the ET4 Pro, so you can try that, but the starting G-code it has by default doesn't do much. It doesn't even draw a purge line at the start of a print. It's literally just 2 commands. As for me, I use Prusa Slicer. Since this printer is mechanically similar to the Ender 3 series, it's a Bowden feed extrusion system with a 220 by 220 by 250 millimeter build volume, I simply cloned one of my existing Ender 3 profiles, and that works fine. I think if Anet were to include documentation about how to set the printer up in Cura with the ET4 profile that's included with it, that would help a lot. In addition, documentation about the printer's motion system would be useful. Maximum speeds in millimeters per second for X, Y, Z, and E, recommended printing speeds, and recommended retraction distance and speed. This information would be welcomed by advanced users of the printer. Now, I've discovered a few weird things about the printer, and most of these weirdnesses I'm going to chalk up to firmware bugs, and there are a few of them. Here's what I've noticed. The automatic bed leveling is usually able to probe the bed without issue, but if the bed heater is on, the inductive probe has serious issues detecting the back left corner of the build plate. When the bed is powered, it's creating a lot of electromagnetic noise, and that affects the probe. As a result, the printer will attempt to drive the nozzle through the build plate. If the firmware would cut power to the bed as the probing was taking place, this wouldn't be an issue. Manual leveling via the LCD just plain doesn't work. You can home the nozzle in the center of the bed and set the Z offset, but tapping the on-screen buttons to move the nozzle to each of the 4 corners of the bed, it doesn't do anything. I tested resuming a print after a power failure by turning the printer off in the middle of a print, waiting a few seconds, and then turning it on again. The printer asked if I wanted to continue the print, and I selected yes, but then the printer unloaded the filament and tried to finish printing. Why? It's kind of hard to resume a print when the printer just unloaded the filament. Also, while unloading, the filament got stuck at the extruder side of the Bowden tube on the way out, and it wouldn't unload any further. The stepper motor just buzzed. Now, it turned out that there was a thicker blob of filament where it had been in the melt zone of the hot end, and it wouldn't fit back out through the Bowden tube fitting. I had to disconnect the Bowden tube, push the filament through in the loading direction, and then snip the end of it off with the flush cutters that weren't included with the printer. The first print after turning the printer on goes fine, but subsequent prints do this weird thing where it tries to move the bed fully forward, even if the bed is already there, and so it pushes the bed past its maximum limit, and then the stepper motor makes this horrible grinding sound. Turning the printer off and on again and then starting the print again works fine. There's nothing in my starting G-code that says move the bed forward, so I don't know why the printer does this. Now, something else really weird is that sometimes if you cancel a print and then start another one, the printer moves very, very slowly. Like that thing where it tries to move the bed fully forward regardless of whether or not it's already fully forward. Yeah, it still tries to do that, but in super slow motion. So then instead of a grinding stepper motor, you get this clunk, clunk, clunk sound until you turn the printer off and turn it on again, and then of course it prints fine. and the printer seems unable to home the Z-axis consistently. I can run the same print job 3 times in a row and get 3 different first layers. On one, the nozzle might be so close to the bed that the extruder stepper motor is clicking because it can't push the filament out. The next might be perfect. And the one after that, it might be so far from the bed it's a wonder the filament's stuck at all. Now this, I think, is the fault of the inductive sensor that they're using for bed probing. I can also run the leveling routine multiple times in a row and I don't get consistent values displayed on that 3x3 grid on the LCD, so I know it's not being super accurate. It can be off by a couple tenths of a millimeter or more between runs, so that may explain why sometimes what's supposed to be a 0.2 millimeter first layer is printed as a 0.1 millimeter first layer or a 0.3 millimeter first layer. The sensor is just inaccurate. Now, of course, I tested the thermal protection features by simulating the separation of the hot end thermistor, that's the thing that measures the hot end's temperature, from the heater block. Now, I do this by unplugging the heater cartridge rather than unplugging the thermistor because I want the printer to be able to read the thermistor. But because the heater cartridge is unplugged, the printer isn't able to heat the nozzle, and the resulting situation is the printer thinks it's applying power to the heater cartridge, and it's reading values from the thermistor that tell it that the nozzle isn't actually heating up. If the thermal protection features are enabled, the printer should stop trying to heat the nozzle once it realizes that nothing's getting hot, and then it should display a thermal protection error so you know what's going on. So with the printer cold, I unplugged the heater cartridge from the breakout board, and then I set the printer to preheat the nozzle to 200 degrees C. And the printer tried, but after a minute or so it gave up. Now on most printers, I would expect a loud beep and a message like E1 heating failed, printer halted, please reset on the screen. Now here, I just got the printer setting the target temperature back to 0. No beep, no message. And also no ability to set the target temperature again. I had to turn the printer off and on again to reset it. Then I performed a similar test, this time heating the nozzle to 200 degrees C and then unplugging the heater cartridge. This time the printer was at temperature and then the temperature started dropping. After a minute or so, the printer realized it couldn't maintain the temperature, so it set the target temperature to 0, and again, there was no beep and no message. Other printers would have given a beep and displayed a message like thermal runaway, printer halted, please reset. Now, just for fun, I decided to try printing a file before resetting the printer, and the printer heated the bed, but it didn't heat the nozzle, and then with a cold nozzle, it tried to print anyway. Now, of course, the extruder just clicked because it can't push unmelted filament through the nozzle. So the thermal protection features work, but they provide 0 feedback to the user. Okay, so looking at the feature set and specs of the Anet ET4 Pro, it's something that can give you most of the features of a Creality CR6 SE at a lower cost. Apart from the Anet having a slightly smaller build volume, both printers have touchscreen user interfaces, both have automatic mesh bed leveling, and both have filament runout sensors. But while the printer's hardware is mostly pretty good, its firmware really lets it down. From weird printing behavior where it does things the G-code isn't telling it to do, to on-screen features that just plain don't work, all these things I mentioned earlier should be fixable by firmware updates from Anet. But the fact that the printers are shipping this way seems to say that Anet is either not thoroughly testing the printers, or they figure they're good enough. I think Anet can do better, and I hope that they're willing to take this feedback and improve the product. But as it stands now, this is just not a printer that I can recommend for anyone other than an advanced user who can cope with or work around its flaws. Well, 3D printing friends, that's about all the time we have for this episode. Now that we're at the end, let's go print something cool. Hey, real quick before you go, I wanted to say thanks for being one of the super awesome people who sticks around all the way to the end, and thanks for all the likes, comments, and shares. And an especially big thanks to those who directly support what I do. You're all wonderful for doing that, and I really appreciate it. If you like this episode, a thumbs up would be great, and if you'd like to help support the channel, check the description for ways you can do exactly that. Oh, I've got some other videos here that you might want to take a look at too. And if nothing else, please consider subscribing if you haven't already done so. It's absolutely free, and it's an excellent way to keep me making these videos for you. Well, that's it for this one. Thanks again, and I'll see you next time here on the BB3D channel.